increase in bandwidth.
Okay, go ahead.
Failover.
So like in the HTTP, as we know that if you have multiple links, so one of your link or multiple link will be going in the blocking state.
Okay, great.
Again, we have a solution like we like RHTTP, we can create multiple links, but another thing you can also bundle this link into one. So logically, it will be a one link, and you can first do the load balancing to it. You will also get a means your bandwidth will be increased. So this will be the reason.
Okay, so normally if you see that you have this is the switch 1 and this is the switch 2, right? And these are my layer 2 ports. So let's say example, we have give the port number. So 0/0, 0/1, 0/2 and 0/3 and 0/4 now we have, right? So different links we have. And if I talk about the speed right now, assume it the speed of this link is a 10 gig, right? So 10 gig link we have, 10 gig link we have, 10 gig link we have, right? And the 10 gig link we have, right? These are the 10 gig link interface. Normally by default, whatever, these are the layer 2 interface, right? These are the layer 2 interface. If this interface is a layer 2, right? If this interface is a layer 2, then what happened? By default, on a all layer 2 interface, doesn't matter. It doesn't matter if it's the access port and the trunk port, right? Doesn't matter if it's access port and trunk port. By default, on all layer 2 interface, spanning tree protocol is enabled, right? And what this guy is gonna do that, it's gonna block all the ports except the one, right? So in this case, what happened? Let's say example, this will be the root bridge. Let's say example, and this is the non-root bridge. If this switch 1 is a root bridge and this switch 2 is a non-root bridge, then what happened? All the ports will go in the DP, 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 and DP, right? What happened? Let me do one thing. Hold on. Let me take a snip of this guy because I need another image. Right? Now, DP, right? DP, DP, and DP. What happened of these ports, right? So these ports will go in the, let's say example, in the RP port, and remaining all the port will be going the blocking. Right? Remaining all the port will be going the blocking. Understand, there is a user behind this guy, switch 1, right? And this is a user behind this guy, switch 1, and there's another user behind this guy, and another user behind this guy, right? These are, I'm assuming it, right? Not like the user, let's say example of the server, right? Because user doesn't require the 10 gig link, right? So server 1, server 2 we have, server 3 we have, and server 4. We know that, right? Server is handling the lots of things, not only handling the one services, they can handle the lots of services, right? Because of the virtualization, they can handle the lots of services over there. So each server, right? Each server requires the 10 gig link right now. Each server requires the 10 gig link. So we have a 10 gig, we have a 10 gig, we have a 10 gig, and we have a 10 gig as well. So user is sending the traffic. User is sending the traffic to the all the server right now. But the problem of what is spanning tree protocol, this girl, what she is doing that? She is very intelligent and she is blocking the ports. She is preventing the loop, right? She is preventing the loop by blocking the ports over there. So eventually what happened? You just have a 10 gig interface to forward the data traffic. So if the PC1 wants to access the server number 1, my traffic will go by the 10 gig link. If the PC number 2 wants to access the server number 2, even my traffic is only following by the 0/1. If the PC3 wants to access the server number 3, still my traffic is going by the 0/1 port number. If the PC number 4 wants to access the server number 4, still my traffic is going by the 0/1 interface. I cannot send the traffic through the blocking port. That's the behavior of the spanning tree protocol. The behavior of the spanning tree is what? I cannot allow the data traffic from the blocking port. So eventually, hypothetically, we can call it, this 10 gig interface, right, is gonna divide it into the 2.5. Again, this is the hypothetical example to understand you. Because I have 4 PC, I have divided the bandwidth over there. So can you imagine it? Now think about it. What's happening over there? I cannot utilize my 10 gig link. So all this bandwidth is totally wasted for me right now. The good part, this is the bad part. The good part that what we have, if the one link goes down, right? If the one link goes down, I have another backup path. But the problem is what? If the link is not goes down, right? If this link is up last 1 year and 2 year, I cannot utilize the bottom link. That's one of the major challenge, right? That's one of the major challenge we have with the spanning tree protocol. A spanning tree is saying that, hey, from the non-root bridge, you will only have a single path to reach the root bridge. A spanning tree, this girl is saying that, hey, from the non-root bridge, you will only have a single path to reach the root bridge. Either, now here I'm going to add some point, either physical, either logical. So any path I want, either physical and logical. If you have a single physical path, I should have only one path, either the single logical path. So to avoid this problem, right, to avoid this problem, what we have done in the 90s time, we introduced the concept of the link bundling. And we can call as a port channel, we can call it a link aggregation as well, whatever name you can call it. Why I call this guy a port channel? Because eventually what happened by aggregating these ports, right, by aggregating these ports, I will create the one path. This path is basically called as a channel. Why I call this guy the EtherChannel? Because this technology, the port channel technology, is only dedicated for the Ethernet technology. You cannot do on the serial link. You cannot do on the serial link. That's why it's called as a EtherChannel. Why I call as a link aggregation? We are eventually bundling this link over there. And these are links are called as the layer 2 links. So what we can do that, we'll bundle this physical link. If you see, we'll bundle this physical link into the one single logical link. So from here, right, from this, guys, please pay attention to the graph right now. From here to here, and from here, right, let me do one thing. Yeah, that's fine. From here, I'm going to achieve this final topology. Right? Switch 1, switch 2, and finally, this logical topology that I have it, the speed of this link is a 40 Gbps. Of course, I will have this name of this particular link. I'll call this guy a, let's say example, port channel 1. This is just a link number, like a Ethernet 1/1, Ethernet 1/2 we have. Same thing, I'm just giving the port channel number. That's a 1 number. So that's a identification of this particular link over there. From the spanning tree, we have bundled this link. And now after bundling, what happened? I get this logical topology. So this is my physical topology, right? This is my physical topology. And this is my logical topology. Now, on this logical topology, right? On this logical topology, what happened? This girl should be up here now, the span tree. So you say that, hey, you know one thing? Now this is the root bridge. This is the non-root bridge. This port will be the DP, and this port will be the RP. Now, do you see the blocking port over there? No, we are not getting the blocking port. What benefits we are getting after achieving the port channel? After aggregating this physical link into the one logical link. This physical link, there's a four physical link we had it. I convert into the single logical link, right? This physical link we had it. I convert in the single logical link. What benefits I'm getting? That benefits is what? We are getting the link redundancy. How? If the one link goes, let's take example. Right now, what happened? We all the 10 gig interface we have. I can send my data traffic from every interface from this interface, this interface, this interface, and this interface. Right? So let's say example, there's a user over there who were accessing my server number 1, server number 2, server number 3, and server number 4. The PC1 for the server 1, PC2 for the server 2, PC3 for the server 3, and PC4 for the server 4. So let's assume it, right? My traffic is going by this way to this guy. My traffic is going by this way to this guy. My traffic is going by this way to this guy. I'll explain you how the traffic will be forwarded. Don't worry about that. This guy. How we are getting the link redundancy over there. Let's say example, what happened if this link goes down. If somehow this link goes down, right, this traffic, right, the PC1 traffic to the server 1, it automatically switches to the any other link over there, maybe the 0/2 now. So if the primary link goes down, 0/1 goes down, then what happened? Automatically my traffic will switch to the another 0/2 or maybe the 0/3 interface. So the user, the server and the user just just get the minimal drops, very minimal drops, and automatically my traffic will switch to the another interface. That's a benefits we have, right? That's a benefits we have if you're doing the link aggregation, or we can call it the ether channel. By doing the ether channel, what happened? My ports are bundled. You will get the single logical link, and the logical link has a speed will be the 40 gig interface. And on that single logical link, I'm gonna run the spanning tree protocol. So I'm not gonna run the spanning tree on this particular part now. Never. We will run the spanning tree over there, switch 1 and switch 2, this logical topology. And that's why the design perspective is what saying that according to the design, you should have a, right, you should have a only one port channel. Let's take example, assume it, if I'm gonna make a bundle of the 0/1 and 0/2 and 0/3 and 0/4 in the different bundle, I have to give the name for this guy the port channel 1. After this, give the name port channel 2. So now the logical topology will look like this. Switch 1 we have a port channel 1 and we have port channel 2. And the switch 2 we have. What do you think that in this case? The logical link. So again, switch 1 will become the road bridge. He will be the non-road bridge. And this port will be the DP, this port will be the RP, and this port will be the DP, and this port will go in the blocking. So if you are doing that, if you have a thinking like this way, let's create the multiple port channel. You can create the multiple port channel on the single switch. But if you have a plan this way, then what happened? Eventually your one port channel will be going the blocking state. Now, to do the port channel, right? Okay, before going to do the port channel, let me tell you one more thing. The port channel, or we can call it the third channel, you can achieve the port channel and ether channel for the layer 2 interface and the layer 3 interface as well. So your port channel can be layer 2, right? Or your port channel can be a layer 3 as well. It means that all your switch port interface, right? All your switch port interface can be a layer 2 port channel. Let's say example, we have ETH1/1, ETH1/2, and ETH1/3, and ETH1/4. I will convert this port interface into the single one. I will convert this port interface into the single one. That's my PO1. This is called as a layer 2 interface, a layer 2 port channel. On this port channel, we are not going to give the any kind of IP address. We are just going to make this interface as a trunk interface, or we can make this as an access interface. Up to you. Depend on the requirement, but no IP address. Whereas if I talk about the layer 3, on a layer 3, what happened? These ports are the routed ports. Same behavior. Let's say example, we have a ETH1, ETH2, ETH3, and ETH4. What I will do that, I will convert this guy into the one logical link. That's my again PO1, the port channel 1. But this port channel is not a trunk port. This port channel has a IP address on this guy. Let's say example 101.1/8. So the first thing is what? The port channel is improving your what? It's improving your link redundancy, which is the benefit. If the one link goes down, my traffic will automatically switch to the another port. That's a benefit we are getting from the port channel. This port channel can be a layer 2 and layer 3, right? Same mechanism to apply for the layer 2 and layer 3 as well. Your layer 2 port channel can be a access port or trunk port. Your layer 3 channel can be a routed port. You can give the IP address on this guy. And on this particular port, you are going to give the routing protocol like OSPF and EIGRP. This port channel, right? This port channel you can deploy in the two ways. This port channel you can deploy in the two ways. One is called as a static port channel. And one is called as a dynamic port channel. Right? The static port channel, if I talk about, of course, as the name suggests that, right, is static. It means that there's a manual mechanism. So there is no protocol. So there is no protocol required to form this port channel. Right? The single mode we have, and that mode is called as the on mode. If I talk about the dynamic port channel, of course, as the name suggests that, it's a dynamic. Dynamic means what? We have a protocol. One is called the PAgP. Another is called the LACP protocol. Right? If I talk about the basic difference, right? The PAgP is a Cisco proprietary protocol. And the PAgP has a modes are called as auto and desirable. Whereas the LACP one, if I talk about, this is the IEEE standard. You can check on the any vendor, Cisco, Juniper, Huawei, Arista. And the modes, if I talk about, this guys are active. As the name suggests that, LACP, A means active or P means passive. So if you're forming a dynamic port channel, you have a two ways, the protocol PAgP and LACP, right? Now, if I come to the data center perspective, what you have a static port channel if you want to form it, and you have a dynamic. In a dynamic, you only have a LACP. So Nexus do not support the PAgP. So if you are running the Catalyst devices, you can do the PAgP. But if you are running the Nexus device, you cannot do the PAgP. Your LACP is there only. Or you can also form the static port channel. Now the question comes in the picture. Many confusion have of people, right? Okay, before I'm going to move to this design perspective, do you have any question, guys? Anybody has any question?
So on layer 3, you said we can use port channels, sir, but by default, like if you do a routing, so it's do ECMP by default. So why do we need means this port channel?
This is a very, very interesting question. I would really love to have this question. And many person has a confusion. Why? Right? So let me, before I'm going to move to this question, anybody has any question in the basic level? Is it clear, guys?
Sir, one more question I have.
Yeah.
Why do we need L3 based aggregation
channel.
when L3 is enough?
L3 based port channel, right?
Yeah.
Yeah, that's the same question. Anyone has any other question? Okay, no. So let me go to the layer 3 port channel. So let's understand this behavior. So I have yeah. Okay, let's go with this scenario. I have a device 1 and device 2. See, we know that we need a layer 2 port channel because of the spanning tree protocol. There is no spanning tree protocol. Then why do we need a L3 port channel? Tell me one thing. I have IP, right? The first of all, if I'm gonna make this guy as a layer 3, if I'm not gonna make the layer 3 port channel, what happened? If I'm not gonna make the layer 3 port channel, I have to give the IP address, right?
Also.
Right? That's right. Now, next thing, what we have to do that? Run the routing protocol. Let's go with the basic EIGRP. EIGRP, I have to enable on this particular interface 0/0. Enable the 0/1 interface. Enable the 0/2 interface and enable the 0/3 interface. Is it right? Now, if I'm going to enable the EIGRP over there, what happened? I'm going to send and receive the hello packet. Receive the hello packet. Receive the hello packet. And receive the hello packet. Now, you told me that, someone has told me that, you will get the backup, right? By default in the layer 3. If the one link goes down, automatically traffic will switch to the layer, another one, right? Someone has said that, right? Now tell me one thing. In layer 3, first of all, right? How we can choose the best path based on the longest prefix match, AD, metric, and the longest prefix match rule, right? That's how your things are working in the layer 3 side. The first problem is what? In the layer 3, without the port channel, I have to configure the IP address on every ports that you can see that, right? So I have to maintain the 4 different routes in my routing table. I have to send the EAGRP hello packet and update packet on every interface. And this EAGRP hello packet is going to consume the almost 90 bytes of packet. That's going to consume the at every 5 seconds. That's a time of the hello packet. The third problem that you have, tell me one thing. If I'm going to change this guy, the metric, this metric is a 10, this is a 10, and this is the 2 and 1. Now tell me, do you see that they will do the load balancing between all the ports?
By default, no.
No, right. Now tell me if I'm going to do the bundling over there. What happened?
Yeah, possible.
I will have only port channel 1. And in this port channel 1, what I'm going to do that? I'm going to run the EIGRP protocol. Once you put this ports 0/1, 0/1, 0/2, and 0/3, once you put this port into the bundle, right? Once you put this port into the bundle, these ports are called as the member ports in the technical term. On which particular port I have enabled the EIGRP? Port 1. So I'm only going to send the EIGRP hello packets on this port channel 1. Now, once the ports are become the member port, you're not allowed to do any configuration on the member port. You're only going to allow to do the configuration on the port channel. So in that case, I cannot change the metric of the interface label I have to go with the port channel label. In that case, I can utilize the full bandwidth not, I can utilize the full load balancing mechanism. I'm not going to send the individual EIGRP packets on an interface label. I can save the bandwidth, I can save the CPU cycle. I can utilize the full interface, I can utilize the full load balancing as well. Is that clear now?
Yes, sir.
Now let's come to this part. So now over here we have a port channel dynamic and PAgP. Anyone has a question till this point? Guys, layer 2 and layer 3 is clear, right?
Yes, sir.
Okay.
Clear.
Now,
Just one query. When you bundle it, it is a must that all the ports should have same configuration.
I'm coming to the point. I'm coming.
Oh, yeah.
So everyone, if you see that we dynamic port channel, we have a PAgP and LSP. PAgP, we do not do that. Now let's go with the question. This comes over there. Why LACP and port channel? Anyone can tell me the difference, the static and dynamic port channel? The difference that I give you regarding the layer 2 and layer 3, like that way. Anyone can tell me? Where should I use the on and where should I use the LACP?
So when you want the connection to go up and down, you use dynamic. So connection starts and stops, and static is it's always on. It will remain no matter if the traffic is there or not. Is that the case?
No. So let's take example, right? A static port channel comes in the picture when you don't know your remote end, right, that support the dynamic port channels or not. Server and the router or switches, maybe, no matter. Do you know that when you're going to make a port channel, do you think that this server is going to support the LACP? I'm not talking the PAgP perspective. Let's leave it because it's the CCNA, CCNP enterprise. Let's leave this guy. Do you think that this guy is going to support it, the server? No, right? You have no idea. Let me tell you, nowadays, whatever the servers are coming, new servers are coming. Recently, I'll tell you, 7 to 10 days back, I have seen that the servers do support the LACP nowadays. Okay. And I have implemented the port channel over there as well. So nowadays, but older times, what happened? The servers that you have, right now, I have the one server. It's a very older, like almost 10 years back. So that do not support the LACP, right? So in that case, what happened if I'm going to make a link bundling? In that case, I have to use the on mode over there. That's how one basic difference. Second difference. Let's take example. Switch 1 and switch 2. I did the bundling over there. If I'm going to use the LACP protocol, right? Then what happened at every 30 seconds, this guy is going to exchange the hello packet. It means that my control plane packets, right? My control plane packets comes in the picture at every 30 seconds. But if I'm going to use the dynamic port channel, so a static port channel, we don't see this problem. Guys, give me 1 minute. I just got one important call. I'll be back in the 5 minutes, okay? Guys, I'll be back in the 5 minutes. I just got one important call, right? I'll just be back in the 5 minutes.
Yeah, sure.
Hey, I'm so sorry. Yeah. So are you there, guys? Can you hear me?
Yes, we can hear you.
Yeah.
So I was saying that, like, switch one will send the hello packet or the LCP packet at the 30-second, and it will also send the 30-second hello packet, right? So can you imagine that what happened? Understand this concept right now. In every 30-second, what happened? My bandwidth consumption will be there, right? At the same time, my CPU cycle also comes in the picture of the switches. So this two problem comes, right, when you're gonna do the LACP protocol. But again, it's up to you how you take this thing, right? Either you can take as a pros and cons. I'll personally take the LSC packet as a pros. The reason is that because if this guy is not gonna exchange the LSC packet, right, they cannot identify which one will become the active and the passive, the situation, the who will become the master and the standby, right? So in the dynamic routing, not a dynamic protocols, right? Even if you check the dynamic routing protocols as well, OSPF and EGRP, and even the LACP, right? They keep extending the hello packets so that they will maintain their neighborship. So whenever the static port channel comes in the picture, remember one thing, this is always recommendation to run it when you have no awareness what the remote and server and devices do support the LACP protocol or not. Because your Nexus devices that you're going to implement in the data center network, you have no idea how this Nexus device is connected. Maybe this Nexus is going to connect with the normal catalyst switch. Or maybe this Nexus is going to connect with the router over there. Or maybe this Nexus is going to connect with the server as well. So you have no idea what kind of devices you are connected. So in that situation, what you can do that, you can just go with the on mode. But if you have awareness, right, okay, I know this remote and switch is going to support the LSP protocol, then I can go with the LSP over there. Is that clear?
Yes, Lord, it is.
Now, that's good. Now, if I talk about in the on mode, what happened? Let's say example, we have a switch one, right? And the switch two as well. So it's a very simple configuration you have. You don't need to enable any features for the on mode. Let me tell you that, right? Normally in the Nexus, what happened? You need to enable the features. For the on mode, what happened? You don't need to enable the features. You just need to bundle this interface and define the modes for this guy just to on mode. That's all. So I will bundle this guy, and on this side, I will call this guy the on mode, and this guy is the on mode. That's perfectly fine. Make sure that both the side you are running with the static port channel. Let's say example, if you configure this guy as a on mode and this guy you want to configure the LACP protocol, the port channel will be never ups, right? So this has to be same on the both side. If I talk about the LACP, in LACP we have a two mode, the active and passive. The simple terminology, if I talk about the active, means what? Active means a switch who has an active role can reach or generate the request to form the port channel, and also it accept the request of forming the port channel. So it means that, right, if you're running with the active, he can initiate the request for the port channel. So let's say example, we have a switch one, and another side we have a switch two, right? And we have called this guy. Let's say example, we have two link right now, right? And I've called this guy as a bundle over there. So I'm gonna make this guy as active mode. So if I'm gonna make this guy as active mode, then what happened? He will send the request to this guy. Hey, you know one thing? These are the ports 0/0 and 0/1. These are the ports that are participating into the active mode right now, and I'm gonna form the port channel with you. So I can send the request, right? If the mode is active. If the switch 2 is also running with the active mode, then what happened? I do have ability. I can accept the request of the forming the port channel, right? So they will also send the request. Hey, also my mode is active right now, and these are my ports, the member ports I have it, and also I want to form the port channel with you. So eventually, what happen? You will have a port channel. If the both sides will be active and active. Let's say example of the passive. What happened? In a passive, what happened? He cannot generate the request. but it accept the request of port channel, right? So let's take example. We have a scenario where I have a switch 1 and the switch 2. I have a two links, right? 0/0 and 0/0, 0/1, sorry. And this guy is active right now, and this guy is a passive. So in the passive case, if you see that in the previously active case, what happened? He can send the LACP packet and say that, hey, my ports are this one. But in this case, what happened? He can request the port channel 0/0 and 0/1. Hey, I'd like to form the port channel with you. But the passive can only accept it and they will form the port channel. They cannot request to form the port channel. So make sure that whenever you're gonna do the LACP protocol, your one switch as a active, another switch can be active or can be a passive. You cannot have a passive and passive both case. If you have a passive and passive, in both cases, what happened? They cannot request to form the port channel. So then nobody can make a request to, hey, let's form the port channel. They will be in the silent mode. So passive are always in the silent mode. They cannot make a request. They can accept the request if somebody is requesting to form the port channel, but they cannot make a request. Right? So many of the times what happen, people do the mistake of this kind of situation, right? They configure the passive and passive, and they cannot form the port channel. Right? So these things are the very basic. Make sure that you cannot enable the LACP one side on the another side on. It cannot work. So both sides will be LACP, and both sides the port role should be the mode should be the active or passive, or either the active and active. The third and most important thing, the question: how many ports you can bundle it? How many ports? Yeah, question.
16.
Yeah, go ahead.
I said 16 port you can bundle it.
Okay.
32, I think. Now the latest.
32. Something else? So I can say the 8, I can say the 16, I can say the 32 as well. It's totally depend on the platform version as well. If I talk about the Nexus one, they do support the 32. If I talk about the Catalyst one, they do support the 8 and 16, right? And if I talk about if I remember that in service point and the XR side, if I'm not wrong, they do support the 64 something, but not pretty sure. So you cannot say that 32, 16 or 18. It's totally depend on the hardware to hardware, right? Like what hardware you have it. So that based on that. So if I talk about the Nexus 9K, right, they do support the 32 port. Yeah, go ahead, Abbas.
Sir, let's suppose I have a funny scenario where I have a switch 24 port or 32 port, and I want to have two switches, and I want to make all of them part of one port channel. Is it possible to do all the ports port channel?
24 ports, you can do that. Up to 32 ports, you can do that in the Nexus.
The entire switch.
Yeah, entire switch, Nexus one. But a Catalyst, you cannot do that.
Okay.
Now, how you can enable the
One query on the previous one, this active passive, the actual scenario or the practically it is only the servers, or you have any other examples where we configure a passive on the other side?
can you repeat your question again?
The active passive mode, right? So you have mentioned servers are an example.
I
where
never mentioned the server in the LACP case. I mentioned the server in the case of port channel, static, on mode.
port channel only.
Yeah.
Okay. So fine.
One more thing, sir, like you said, 32 port can be means aggregated in the port channel. So will this 32 port will be active, or like some of the ports are active? How it's going?
In Nexus, you can have 30 ports to 32 ports will be the active one.
By default, it is 32, or like
by default, it's a 32.
okay.
But in the Catalyst, you cannot do that.
I think in Catalyst we have 8.
Yeah, Catalyst, what happens? Let's say in example, you have a 16, 8 port will be the active, and 8 port will be the standby.
Okay.
Now, how we can enable the feature first of all? So you cannot directly go and create the port channel on the Nexus devices. You cannot go and say that, look, let's make it the interface port channel and create the channel group 1. You cannot do that. So first of all, you need to enable the features. So first feature is called as a feature. Okay, for the on mode, right? For the on mode, you don't need to enable the features. This is the interview questions, right? They will go how they will put the question. So to enable the feature. So they will ask you the question, hey, tell me one thing. I want to make this guys a port bundling. I want to make this guys a port bundling. These are the Nexus 9K1 and the Nexus 9K2. But you're not allowed to enable the features. You're not allowed to enable the features. So how you can do that? So this scenario-based question, you will get that in the interview of the Nexus. So simple, you have an on mode. So for the on mode, you don't need to enable the features for this one. Now, for the LACP protocol, what happened? You need to enable the feature because this protocol is by default, right? LACP is by default disabled. So how we can enable it? You just need to go on this feature and LACP. That's all. So once you set the feature LACP, then what happened? The feature will be enabled for the LACP, and now you are good to go and enable the active and passive mode over there. How we can do that? Let's take example. Let me turn on the devices. Hold on. I need to go to my base PC.
One thing, like we are enabling this feature, so this feature is also license based, or like if you do buy
This comes in
something,
the base license.
all features.
LACP feature.
Okay.
For the LACP feature, you don't need to buy any extra license for them.
Okay.
Hold on, guys. I'm on the RDP of the different desktop right now. Let me print the base PC. So let's do one thing now. I will create the scenario where I can show you the how I can do the 1, 2, 3, 4, and okay. So I will create something topology like this way. So where I can show you the multiple port channels, right? So let me do that. So PC and oh, what happened? PC and let's add the 1, 2, 3, and 3 is fine. So I will have multiple port channels. No, I need to Nexus 9K. And 3.10 and 3.10, right?
I think you have added 7K.
Sorry?
Oh, no, that's
Yeah, I give the
okay.
7, right? By mistakenly. 1 minute. 1654. So 1 should be there, 2 should be there, and 3 should be there. So what we can do that? Let me remove this guy. I don't need it. Okay, let's leave it. If I need it, then I will add it over here in future. So no, 1 minute. Two. Okay, so between this guy to this guy, I have 2 ports, right? And between this guy to this guy, I have 2 ports. And here I have 4 ports. Okay. So how many protocols I need to do that? Sorry, protocols will be the one, LACP of course, but I will have multiple port channels, right? So let me start this guy. So once your ports are become the part of the port channel, right? That ports are called as a member port. And once the ports are the part of the port channel, you cannot change the any configuration on the individual ports, right? Let's take example. These ETH1/2, right? ETH1 and ETH1/2. These are the ports that I map to the bundle of the interface, the port channel 1, right? So once I made this guy as a port channel 1, so under the port channel, what happened? You will have a ETH1/1 and ETH1/2, right? So this is the part of the port channel 1 now. You cannot modify any configuration on the individual port. After that, you cannot do that. So if anything you want to modify it, you have to modify under the port channel 1. Meantime, this will be started. Let's me go through the LACP next, not Nexus port channel Nexus 9K.
Sir, what are we doing in the lab? What are we trying to achieve?
I'll show you that. So we'll make a bundle of this guy, right?
Yeah.
Via the LACP protocol. We'll make a bundle of this guy via using the on mode over there, right? Just to show you that this guy doesn't require the LACP to be enabled. So I'm only gonna enable the LACP over here. Is that clear now?
Okay.
Okay. So let me show you the few things that read this one. So your port channel either can be a layer 2 interface. Just read the important point. That's want to show you that. So you can bundle the up to 32 links, active links into the port channel. So there will be no standby. You know, active links within the port channel. Increase the bandwidth and the redundancy, right? So standby should not there. So you will have a 32 ports will be active, and you can have a layer 2 and layer 3 port channels as well. Right? Layer 2 is a access port and trunk port. Layer 3 is a routed ports. Right? The important point, after the layer 2 port channel become the port channel, all the switch port configuration, whatever the configuration you want to do the individual port, it cannot be done. So you have to do under the port channel only. You can no longer apply the switch port configuration to the individual port channel members. Members means what? ETH1/1, ETH1/2, right? Yeah, Abbas, go ahead.
Sir, you said once they have become a part of.
Once the part of.
Yeah, so whatever configuration was there before, what happens to that? Like maybe it was a trunk, maybe it was a access port, maybe it
So
was
that I'm coming to the
actually.
point. That's so before adding in the port channel, right? Before adding to the port channel, what happened? That's the best recommendation is what? You can remove all the configuration, right? That's the best part. You can remove all the configuration and then apply the configuration under the port channel. So you need to make the interface as a default. That's the best part to do the configuration. You need to make the interface as a default, and then you can apply the reconfiguration on the port channel members. Right. Second thing, once the port channel become the member of the ports, right? There's some criteria. The criteria is what? Your speed has to be same, right? Your duplex has to be same. Then your what we call the ports has to be either the access port, right? Either the trunk port. So make sure that if this is the access port, so also be the access port. If there's a trunk port, then also be the trunk port, right? Then after that, what we have the allowed VLAN. So if it is a trunk port, so the VLAN allowed should be same, right? And the protocol has to be same. Protocol means what? The LACP. So these are the major important thing. Protocol has to be same. So these are the major things that has to be same if you are making the port channels, right? One more thing, you can make the port channel. That's another interview questions. Let's say example. So normally Nexus devices are coming in the line cards, right? So let's take example. We have a Nexus 9K, any of the 9K model, right? And I have a line card 1, LC1 and LC2, right? LC3 and LC4, right? So you do have ability. You can take the 0/0 port number from here. You can take the 0/01 port number from here, and you can take the 0/5 port number over here and 0/6 on. So you can make a ports from the different line card, and you can bundle it as well. It's possible. You can do that. And in production, I'll tell you, you are doing this way only. Not only this way, the reason is that we're doing this way. So let's say example, I'll give you the two scenario right now. So I have a LC0, okay? And I have LC number 1 and LC number 2. So what happens if I have 0/0 and 0/1 and 0/2 and 0/3? If I'm gonna bundle all these ports, right, they all belong to the LC0. You can achieve the load balancing, right? You can achieve the load balancing. But what happens if the LC goes down? LC is just a hardware, right? Line card is just a hardware. What happens if your line card goes down? If your line card has a faulty, then you need to do the raise the RMA to the Cisco. Cisco will give the RMA product. Till the time if you don't have a another part in your data center, then you have to raise the RMA. RMA will go to the Cisco, Cisco will reverse back to the RMA, and then you have to again put the LC over there. Right? So what solution that you have, right? Port channel is not increasing the, listen to me carefully, port channel is not giving the linked level of redundancy. If you use the port channel, in a better way, right, then you will also get the module level of redundancy as well. So if the one model goes down, let's say example in this case, right, if the LC1 goes down completely, then what happened? My traffic will go by the LC number 2 and LC. Even the LC number 2 and LC number 3 goes down, even my port channel will be up. My traffic will go by the LC number 4. Is that clear?
But in that case, you have a interface from import channel from every LC, no? That is only
Yeah,
possible.
that's every. Not every LC you're not made. So I cannot make a LC number. This is LC number 5, right? I cannot add any port from the LC file. That's fine. I don't have a requirement.
Okay.
Okay. But this is the good bit that you can do that. I'm telling you, right, out of the 10, right? First of all, the port channels are there everywhere you will encounter it. Everywhere you will encounter it. Layer 3 and layer 2 port channel, everywhere you will encounter it. Right? But the best way, if you see that, whenever now you guys start doing the troubleshoot and the configuration of checking start checking the configuration of the customer network, how they do configure it. Check the member ports and check the member ports from which line card is there. That's how you can improve your knowledge, because in the interviews, what happened when they are putting this question like this way, right? So people get confused. Okay, will it work or not? I don't know. Is that clear now?
On a DC, like for every physical interface, you have one port channel. Like
Even I
MLAG
have
or
seen that.
Yeah.
Even I have seen that one port channel, one interface, they made the one port channel.
Yeah.
Yeah.
We have Nexus and Arista, so they have configured MLAG for MLAG for every single interface, they have configured port channel.
Right, man. So the Nexus do not support the PAgP protocol, first of all, right? You can ban the 32 links that I have told you that, and so they have shown that your port channel can be the layer 2 access, so the layer 2 trunk and the layer 3 as well. The ports will be routed in the layer 3 case. The ports will be trunk, and the ports will be access in the case of access. You cannot mix match, right? You cannot do that mix match. The basic setting, duplex, IP address, MTU, this has to be same, right? Speed, allowed VLANs, trunking, native VLAN, it has to be same, these things. It has to be matched, right? So mostly what happened, what different fields you will get that, I'll tell you. Whenever you are doing based on the line card to line card 1, line card 2, line card 3, then you will face the difference over here, right? Duplex are right now, whatever the devices are coming in, whatever the maximum devices are the full duplex. So you don't have any issue with the duplex part. Yeah, some of the line card you will face the encounter of the trunking or the access part issues. And some of the, if they have improved the security at the VLAN level, so you will have a mismatch of the native VLAN as well. So basic things is what? The trunking, access, speed, native VLAN, what VLANs are allowed, this has to be same. MTUs are almost same on every way. People do not change that. First of all, it's never recommendation to change the MTU. It has a huge impact. Okay. So it's never recommendation to change the MTU. But yeah, some situations coming where we need to change the MTU as well. But mostly you will find the same thing. So basic things is what? Speed, duplex, ports will be the access or the trunk, what VLANs are allowed, and the native VLANs. Then after that, how the load balancing, I will see that later. Don't worry. Let me go to the lab and let's do it. So switch 1 we have. Yes. Switch 2 we have. Yes. And switch 3 we have. Yes. I'll draw the topology over here so that you can see it. So we have a switch 1. We have a switch 2. And we have a switch 3. We have two ports. So ETH1/1, ETH1/2, ETH1/3 and 4, and ETH1/1, ETH1/2, ETH1/1, ETH1/2. And I have ports over there, 4 ports. Which ports are there? 3, 2, 4, 5, 6. 3, 2, 4, 5, 6, and say the 3, 2, 4, 5, 6. Okay, let's go to the. So the password for the switch 1 now we have. All good? No. Come on. All good. So admin, just go 1, 2, 3. So I'm on the switch 1 right now. Okay, let me change the host name. Switch 1. Right. So my plan is what? Let me turn on the interface right now. What are the interface? Let's go with the switch 1 right now. So switch 1 is planning to do the on mode. So here I'm planning to not to run any protocol over there. So I have an on mode over there, right? So what we can do, the first of all, we need to go under the interface, right? How we can go under the interface? We need to go under the interface ETH1/2, right? So I'm gonna bundle this guy. I'm gonna bundle this guy into the PO1. And I'm gonna bundle this guy as a PO2. Right? Channel group, that's a PO1, and also the mode will be on. That's good, right? That no protocol has been enabled. And same thing, I go to the switch 2 now. This is the no. Switch 2 is same interface, ETH1 and ETH2, right? Admin. Switch 4, 1, 2, 3. Config terminal, host name switch 2. Right? ETH1, ETH2. Channel group, mode on. Exit. That's done, right? Let me go to the interface ETH1/2. No shutdown. And same thing on the switch, this guy as well. No shutdown. Because by default ports are down, right? That's all. So now if you go to the Nexus 1, show port channel summary, you can see that. Okay, hold on. I haven't changed the ports status. Switch port. That's done. And I cannot change anything in the member port, so I need to go to switch port. So by default, the ports are the layer 3, right? I need to make this guy the layer 2. I forget that. I have another image of the EBNG where the ports are the layer 2. So now that, so port channel summary. So you can see that the first thing on the switch 1, we have a PO1, right? The port channel 1. S means this S flag is going to represent that it's switched, right? And the U is going to represent that this in the upstate right now. The type is Ethernet, right? The Ethernet, because we are using the Ethernet type cable over there. And the protocol is none. The protocol none is just going to tell you that we are running with the on mode. We don't need to use any protocol over there, LACP and PAgP. And whatever the member ports I have, ETH1 and ETH2, they are in the ports are in the up state right now. Okay. So that's a static port channel. I haven't enabled any kind of protocol over there. So if you see the show port channel member, what was that? Not this one. So interface port channel 1. Yeah. So you can see that my bandwidth, right, has been aggregated now. right? My bandwidth has been aggregated for the port channel. So Ethernet 1/1 and Ethernet 1/2. So the bandwidth has been equally divided. So the 100 Mbps and 100 Mbps for this guy. I think so 1 Gbps for this guy, 1 Gbps for this guy. Now it becomes the 2 Gbps. Same thing if you go back to the switch on this interface 3 and 4. So I have again on mode, I'm going to use it. So what we can do that? So interface ETH1/3 and 4, right? First of all, no shutdown command. Let's leave it. I'll say the switch port first of all. Let's make this guy's a layer 2 interface. So the channel group will be what? It's a 2, mode will be on. Same thing on the switch 3 now. Right? On this particular interface, ETH1 and ETH2. Hostname switch 3. ETH1, ETH2, right? I'll say the switch port. Channel group will be 1, mode will be, sorry, channel group 2, mode will be on. That's done. All good. And let me turn on this interface. No shut. And no shut this guy as well. All done. So if you go back to the switch 3 now and see the source port channel summary, and my ports are in the upstate, right? So between this guy to this guy, I've configured the on mode, right? So there is no any protocol packets are going to be getting exchanged. Yeah, Bas, go ahead.
So this is great. Understand. In real life,
Mm-hmm.
why would we keep these channel ports as access for switches?
I'm coming to that point as well. Hold on. Let me configure this part and I'll come into the question as well. Okay. Let's go with the lab first, then I'll come to the lab. This one. So on the switch 2, so I have we'll make a design label, all the production label issues on the last. Don't worry about that. Interface ETH3 and 6, right? So I have okay. First of all, if you see the channel group, and I'll put the any group number. Let's say example, I have a 10 right now, right? And if I'm going to say the mode, put the question mark. It has an active and passive. But they are saying that the LACP process needs to be restarted before configure the active and passive mode. So you can do the on mode without enabling the LACP, guys. Please, it's a very, very important. Lab is a different way right now, but if you're planning for any interviews, it's very important. So for this thing, what we have to do that we need to first enable the feature that's called as a LACP, right? I have to go to the feature LACP, and now I can put this command interface, same range, channel group. Let me make this guy as a 10. So I'm gonna bundle this guy now into the 10. And I'll say the mode will be what? Active. Done. Switch port. Let me go to the no shut interface port channel 10 switch port, right? Because once your port will be part of the port channel, you cannot do any configuration. So I have to go under the port channel and say the switch port. Same thing on the switch 3 now. The switch 3 as the feature LACP protocol. And then once we enable the feature, then I need to go to the interface E326. I'll first the most important switch port because this is the layer 2. And so channel group will be what? 10. Now mode will be what? If you want to make the activity, you can make it activity. If you want to make the passive, you can make a passive. Up to you. So let's make it the activity right now. Not a big deal. And what we can do that? I'll say that that's done. No shutdown. So now you can see that. So port channel summary. I have a protocol for the group number 10, right? The port channel 10. Ethernet protocol is LACP now. None is for the on mode. And our how many member ports we have? The ETH 1, 2, 3, 4, 5. And they are in the upstate right now. Right? They are all in the port channel in the upstate, the member ports P. The P flag is going to represent in the upstate right now. If you see this topology, I have all the ports are in the upside. Now I can go to the switch 2 and have a look. So interface port channel 10. Can you see that? For this guy, the link aggregated bandwidth is almost 2 Gbps. What's that? Hold on. Because we have only 2 links, right? But for this guy, if you see, I have 4 links. 4 Gbps, right? So bundle state is up right now, right? Admin state is up because I manually up this guy. And now you can verify one thing. So port channel and traffic. I can see that some of the traffics are going on this particular interface, right? Also, you can check that. So port channel. And there was a command. 1 minute. So LACP.
Are you looking for the counters? LACP
No.
counters.
No, not LACP counter.
Okay.
Port channel. There's a command will show you the member ports, man. I don't think so. It's there.
Okay.
So in a single shot, is there a
When
real box?
interface port channel will show.
No, that's not coming. So interface port channel.
Mhm.
No,
It will display, right? You just
yeah,
wanted
it's
to see,
displaying
right?
that it's
Yeah.
in the real
Yes.
box.
Yeah,
I
we
don't know
brief.
is there or not. Even in the
Yeah.
I have the image is there. So LACP port channel. Let me 1 minute. Hold on. Let me check it. Port channel and interface. I don't think so. They will give it. No, that's port members is not coming away. So
The members are coming over.
It's there,
3,
no?
4, 5.
Member port.
member ports are coming, but
Yes.
there is a command that will show you the complete running configuration. What member?
Okay.
Okay.
That's not there. Now, interesting part if you see that we did the port channel. Now tell me one thing. My logical will be something like this, right? Understand this concept. My logical something look like this way, right?
Yeah.
Right now? Hannah?
Yes.
Okay. Let's go with the slide. Switch 1, the first one. You can see that the 5001, the 5002, and the 5003. Right? Here's the road bridge, of course. Here's the DP, RP, right? DP and blocking and RP. Now let me tell you that this is the port channel 10, port channel 1, port channel 2. If you see on a switch 3, the reason to show you the lab, I can make this port channel into the 2 switches, and that's well fine. But the reason to show you this topology, to understand the behavior. By all the 4 gig interface, that 4 bundle.
Block.
Are in block in state actually.
Under
Bad
optimized.
design.
Bad design.
If the PC 1 wants to communicate with the PC number 2, how the traffic will follow? This way. What is the use case of the LACP protocol over there? Is that clear now? So you have to be very careful, right? Forget the configuration part, right? The configuration, I'll give it to you in the notepad as well. That's not a big deal. But understand the logic. Your one simple mistake, right? Normally, network engineers do configure the things, right? They don't care about it. So when I started this configuration, I don't know anyone has think about it. This config, this topology is bad or not. So the point that I want to mention over there, being a network engineer, you need to start thinking about the design perspective as well. Because if you don't think it, then what happened? The problem comes in the picture.
Sir, what if we change the design and we make S2 as our root? Then everything is solved.
Yeah, then it's fine. But default is what? The
Make
port
it a
channel
root.
10 is going the blocking state. Is that clear?
Yeah.
Okay. Let's do this way right now. I'll make a combination of this thing, right? I'll go with the what I can do that in this scenario. Can I make this guy L3 port channel?
No, sir, just change the priority.
Yeah,
custody
we
priority.
of course we can make this guy the root bridge, then things will be fine,
Yeah.
right? Let's
Yeah,
do
yeah.
the let's make the layer 3 port channel, right? Of this ports. It's good now?
Okay.
Okay. So the L3 also comes in the picture, right? So what we can do that under the interface port channel. Dude, you are not a switch port now. When you're not a switch port, I can give the IP address 10.1 dot. Let's make a 1 NOS to 23.3 for the R3. So that's 24. No shit on the switch 2 as well. Interface port channel 10. No switch port. And your IP address will be, come on, 23.2/24. No shit. Now good. So port channel. Okay. And now you can see that the interesting point, the flags has been changed. So the previously flag, if you see that, I don't know why it's sometimes this EVNG has an issue, man. Previously the flag, if you see, come again.
It's changed from SU to RU.
Yeah, that's why I'm showing that. Yeah, so if you see that the flag was SU, S means what? It was a switch, right? And U means what? It was a layer 2. Sorry, up port channel. But now if you see on the Nexus 2, it's become the RU. R means what? It's a routed port.
Route.
And U means what? It's a up channel, right? Is that clear now?
Yeah.
What we can do that? Let's leave the EtherChannel right now, otherwise get people confused, man. No feature EtherChannel. So anyone has a big problem till this point. So these port channels are the layer 3 now. We have a IP address on the, this guys are 23.2 and the 23.3 now.
Sir, how the traffic will flow now? Because
Okay, that's coming to the point. Now next question is coming, traffic flow. So if I talk about, right, the traffic flow in port channel, right, the first of all, let me tell you one thing, the load balancing, right? Before I'm going to do the load port channel, I'll tell you the load balancing. The load balancing you are achieving in the Cisco devices, two ways. Either you load balance the per packet and the per flow, because of the per distance as well. Right? What do you mean with the per packet? The meaning of per packet means what? Let's say example, we have router number 1 and we have a 2 links, right? So let's say example, this is the PC over there, and this PC has another PC over there, right? And they have sent the packet from here. So they send the 10 packets, right? So the 5 packets will be go from this side and 5 packets will go from this side. That's a per packet. Do you see the problem in this per packet? Do you see any problem in the per packet? No? Anybody?
Sorry, Lo, just distracted actually
Okay.
for
So
can you
load
just repeat
balancing,
it?
load balancing is categorized in the 2 ways.
Correct.
Per packet and the per destination. When I'm sending the 10 packets from the PC number 1 to the PC number 2, right? Right now the behavior is the per packet. So I will send the 5 packets from this interface and 5 packets from this interface. What is the problem in this mechanism? Now let me make a more simplified. This is the 10 giggling.
The return traffic,
Sorry?
does it make a sense? Return traffic, anything?
No, forget the return traffic right now. Just send it.
Okay.
So now I'll make them more easy now. It's a 10 gig, it's a 1 gig. Now, do you see any problem?
So your 1 gig link will be more utilized because it's a 1 gig.
Yes, correct.
Forget the utilize right now.
Okay.
Utilize the simple is a 10 gig
the
link, so 10 gig will
buffer
be more utilized.
buffer size is, does it creating an issue here? The interface buffer. Okay.
Reordering,
And with mismatch, yeah.
right? Reordering will we need to do that on the router number 2, right? So during the reordering, do you know what happened? R2 has to utilize the CPU cycle.
Right.
This mechanism, it was there in the process switching, right? If you guys remember that, there is a 3 types of switching: fast switching, process switching, and SEP. It was there in the process switching, but it's not there in the SEP nowadays. SEP nowadays is going to use the pod destination. So in the pod destination, let me clarify more thing now. If the 10 packet is coming, right? If the 10 packet is coming, right? For 10 gig, 1 gig, no matter. Let's make it simple right now. Let's go with the 10 gig right now, right? So if the packet is coming on the router number 1, what router 1 will do that? It will perform the load balancing based on the destination. So let's say example, there's a 102 IP address. This is the 101 IP address. So it will find the hash value, right, of the complete packet, right? And after finding the hash value, it will choose the any one of the interface. Maybe they will choose this interface. So all my 10 packets will go by this interface only. After some time, let's say example PC number 3 we have, and PC number 4 we have. They wants to communicate to each other. So this guy's IP address will go on 103. Guys, please pay attention. This will be clear your port channel concept. So now if this guy's gonna send the packet, right? In that case, what happened? They will have a source IP and destination IP 103 and 104. They will perform the hash value, right? This hash is the internal process of the router and switches as well. And based on the hash, what happened? They will identify this packet, this interface I have to use to forward the packet, right? So 10 packets will go by this way. This is called as a load balancing. Load balancing doesn't mean that you're equally dividing the traffic. It's depend on your IP addressing. Let me tell you, have anyone heard this term, load label design?
Oh,
LLT?
no, sir.
No.
LLT
Yeah,
I've heard,
LLT
but
is
I've not worked on it. I'm not designed anything, right? But I've heard the word LLT actually. Low
Okay.
latency something, right? It is.
Let me tell you one thing. Whenever the network is getting designed, right, the designers and the architect know the in or out what IP I have to put it over there. Your IP make impact your router forwarding, dude. And let's say example, what happened if your all IPs, right? It's gonna utilize this link only then 10 gig and not the bottom link. Then have anyone heard this term traffic polarization? Guys, I'm a little bit different from the LACP right now. I'll coming to the LACP. Let me come to this point because this is the basic concept of the load balancing. Have anyone heard this term traffic polarization?
You're saying about QS?
No, forget the QS
Nothing,
right
right? Okay.
now. No. Traffic polarization.
It's a polarization. Okay.
Traffic polarization means what? The meaning of traffic polarization means what? Your one link will be overutilized, another link will be not. So your 90% traffic will be go by the upper link and only 10% traffic will go by the bottom link. That's the meaning of traffic polarization. So one link is overutilized, another link is not. And this happened due to your bad design of your network. Either you have configured the wrong load balancing mechanism in your network, either you have configured the wrong configuration of the IP address subnet as well. So you have to be very careful whenever you're designing your network. I'll give you the one documents, guys. Okay, cannot go through this one, but I'll go give you the documents. Please read it. Yeah. I'm putting in the chat right now. Go through this one. It's amazing. This will give you the understanding of the. I can't send the math. Okay, it's everyone. Yeah. This will clear the concept of your pluralization part. Now let's come to the LACP now. If I talk about the LACP, right? In a LACP protocol, right? The switches is gonna identify which port or which member port should I use to forward the packet. I have a multiple ports, right? So let's say example, we have a switch 1 and we have a switch 2. Which port should I use to forward the packet? The 0/0, 0/1, and 0/2, and 0/3.
Based upon the destination map.
No, it's totally depend on the behavior. So what are the load balancing algorithm we have? First of all, let's see. So we have a source map. We have a destination map. We have a source plus destination map. Can I call this as a layer 2? Because all the MAC is there. Then we have a source IP, destination IP, and the source and destination IP. Can I call this guy as a layer 3? Then we have a source port. Then we have a destination port and source destination port. Can I call this guy the layer 4? So you have a layer 2, layer 3, and layer 4. The good part, Nexus do support this guy, port 1. So you have a 9+ algorithm mechanism, right? Where the LACP can choose which path I have to go. So it cannot, see, understand, after creating the logical topology, you will have a logical something like this way, right? You cannot forward the packet through the logical link. Packet is still going forwarded by the physical interface. Packet is still go by the physical interface. It cannot go by the logical one. Never. Packet never will go by the logical one. It's always go by the physical one. Which port I have to use? So let's say example, PC1 wants to communicate with the PC number 2, right? What algorithm I'm using it? Per destination basis, right? Not the per packet. So per destination, what happened? Any one of the link, I'm going to use it, right? Any one of the link. I cannot use all the links to forward the packet, right? Never, cannot. It's not a per packet. So either I'm going to use the 0/1, 0/2, 0/3, and 0/4. So this depends on the which algorithm you are using it. If I talk about the non-IP traffic, whenever this, you will get this term, non-IP traffic. Don't confuse with this bhari term. This is the, I know this is the bahut bhari term, hai? But don't confuse. The non-IP traffic means what? The MAC address traffic, the layer 2 traffic. Whenever this terms comes in the picture, always remember that your default behavior is our source and destination MAC. So if you see that, even if you go, okay, I'm so sorry. I'm on the desktop right now. Hold on, let me go to the, come on. Yeah. So if you see, so port channel, load balance, for the non-IP traffic, right? What's the default algorithm I have? Source and destination MAC. So let's take example of the MAC address of this guy's A and the MAC address of this guy's B. So what happened? They will find the hash value for this guy. They will perform the algorithm and they will find the hash value. And whenever this hash is going to identify, it will identify which port I have to use to forward the packet. So it will perform the hashing for both the guy if you're going to use the source and destination MAC. If I'm just going to use the source MAC, not the destination MAC, in that case, what happened? I'm only going to perform on this particular portion, not to the B. If I'm going to say that, hey, you have to choose the destination MAC as the algorithm for the load balancing, then in that case, I don't care about the A, I have to care about the B. So based on the B, I'm going to choose the interface. So hashing will be done on this part. Hashing will be done on this part if you're going to use the source MAC. And hashing will be done on the both part if I'm going to use both the things, source and destination MAC. Now think about it. Just go back in the LLD concept, low level design. It matters. It matters. You cannot say that. Switch, hey, you know why you are not sending the traffic from the 0/1 and 0/2? Why they will send it? You configure your LACP protocol. Guys, are you there with me? Can you hear me?
Yes, sir. We can hear you.
Sir, we can hear you.
Yeah, hello. Yeah.
LACP, right? LACP is a protocol. Default is what? Source and destination MAC. Have you heard this term? Like when I'm manipulating something in the switch side, in the LACP side, it will be impact to your current traffic, man.
But sir, we are employing LACP to take care of it. Why do we need to worry about it?
You are applying the LACP, but what happens if I want to change the load balancing algorithm from the source destination MAC? Let's take example. According to the source and destination MAC, my port is being utilized by the 0/1 to forward the packet for the A and B, right? And for the, let's say example, we have another PC, the C and D, they have a MAC address. They are also utilizing the 0/2 port number. And this is good because of my algorithm, source and destination. But what happens if I'm going to change the MAC?
But sir, the source and destination MAC are for the switches, not for the end devices.
Who told you that?
No, it is
No,
for the
it
PC, I believe.
is for the this one, right?
It's for the user.
Yeah,
Users.
correct. The user systems MAC address actually.
Oh,
It is
okay.
It's basically on the frame, right?
Uh-huh.
Basically
Now
on the
understand
frame.
one concept,
Yeah.
guys. Please pay attention. Let's
Okay.
take example. I have removed the D right now. Understand the logic behind the port channel load balancing. What happened if the C wants to communicate with the B, and my port channels are the source and destination MAC? I can use the 0/2 port number. No problem. I can use it. Right? So it means that if A wants to communicate with the B, my traffic is going by the 0/1. If the C wants to communicate with the B, my traffic is going by the 0/2 port number. That's fine, right? But what happens if I'm going to change to this guy to the destination MAC? So my A to B and C to B, I'm going to perform the hashing for this guy. I'm going to perform the hashing for this guy. Let's say example, I choose the 0/1 interface. In that case, what happened?
The both traffic will be going on one first interface itself. It's a destination is same, right?
Destination is same. Problem will what? This link will be overutilized now.
Correct.
And this link will be underutilized. Traffic polarization comes in the picture. Is that clear?
Clear.
So you have to that's what I'm saying to everybody, right? Before manipulating any single thing, forget them. Even if you're manipulating the metric of your routing protocol, it's going to complete impact to your entire network.
So this means that we have to take care of all the endpoints before we.
Yeah, man. You have to. That's why I'm saying that you need to talk to your architect before being a network engineer. See, after doing the CCNA, CCNP, CCI, right? What you think, what you will become? Architect? Of course not. The first you will go with the layer 1 job, then you have to go with the NOC job, then you have to go with the network engineer, then I'm supposed to become a network engineer, then you have, if you want to become the expert in the some field, then you have to go in the tag. Once you become the tag, then you have to become the TL. TL means what? You have to become the understand the topology of the every network. TL means what? You have a complete understanding of the network, right? Guys, give me 1 minute. Hello? हाँ बोले हाँ भैया पापा को भेजते हैं Yeah. Can you hear me now? I'm so sorry. So, yeah, traffic policy comes in the picture. So you have to be very careful. So once you become the TL, right, tech lead of any company, so it means that what? Why you are tech lead? Because you know in and out of the every topologies. Once you become a TL, right, then your what we call your profile is coming to the principal engineer and the architect level. So till that time, you need to know in and out everything. And that's why when the people has the experience of the 10 years and 15 years, that's why they are doing the data center technology, they are doing the service provider technology, they are doing the CCD as well. Configuration, doing the configuration on the box, do you think that's a great job? No, you can copy and paste it. AI can do that for you, man. Doing the troubleshoot is an amazing job. Being an architect is an amazing job. Even like when you become a tech engineer, let's take example, what happened? You're just gonna suggesting the customer, hey, you have to change the algorithm. But you are also mentioning them, hey, change the algorithm, but make sure that you have to coordinate with your architect team or internal team. So that they will coordinate and talk to the internal team, and based on that, they will change the behavior. You are not allowed to create any single loop back interface, man. If you create a single loop back interface, it's going to impact to your complete network as well. Because what happened if your host process will be restarted and the higher loop back will take the precedence of the route ID, all gone.
सर आपको डरा रहे हैं
No, I'm not denying. I'm just telling you that the importance of the job, networking is very important. LACP, right? Whenever you talk about the port channel thing, right? You have to be very certain which port channel should I use it and which will not use it. For the layer 3 side, if you see, I have the same source plus destination plus IP plus the interesting point over there, L4 port. It means that what? When the load balancing will happen for the layer 3 traffic, when the load balancing will happen for the layer 3 traffic, in that case, what happened? Your L4 port hashing also comes in the picture. Now you may have a question, hey, what happened if the packets are the layer 3 ICMP packets, not the layer port numbers are there? In that case, this bill will be ignored.
Sir, what about the this one, right? Rotate 0, what does it do actually?
Rotate 01 ka, I have never idea like what is the meaning of this one. I'll check.
Same here actually. I have not checked that one actually before.
It's not there in the. I'll check it and let you know if it is.
Sure, no problem, no, fine.
Port channel, load balance, and you can see how you can manipulate the source and destination. Right? I can manipulate the algorithm if you want. Source and destination IP, source and destination MAC, whatever you want to do that, you can do that. So let's say
But
example.
sir, this L3 load balancing, is it different from the iOS one? Because in iOS one, what I know that we have something known as draw table in which we take the binary
Same
large
thing
bit.
is happening in the Nexus as well. Same thing is happening in the Nexus. So same the XOR table, you're going to do that. If you have a source MAC, then you don't need to do the XOR. You have a destination MAC, you don't need to do the XOR. If you have a combination of the source, destination MAC, then you have to do the same thing, source and destination IP, then you need to do the XOR over there. Yeah, that comes in when you learn the CCNP, you are getting to know this point as well. Yeah.
It means we also do this in Nexus.
Yeah, same thing in the Nexus as well. Same behavior is happening everywhere. But when I told you the same thing, right? Understand the important concept. What the devices is doing for you, you don't care about it. Technology is very important. If the devices is doing for me, why should I learn it? Those things, the XOR operation, right? Yeah, we are learning those part in the CCNP enterprise when you are learning this thing, because on that time what happened, people are very, very fresher about the port channels. So we do teach this, okay, this is the XR operation and this port will choose and they are happy. Oh my God, finally I got to know that which ports the switches is chosen to cover the traffic. But yeah, and data center perspective, you need to understand the high level concept, like layer 3 port channels, layer 2 port channel, what things I need to manipulate, what not things I need to manipulate it. Is that clear, guys? Anybody has a doubt till this point? It's clear, everybody?
Yes, sir, we got it. So you mentioned that there are 9 protocols, 9 algorithms,
Yeah,
3
there,
for
man.
each. 3.
Also that.
Yeah, these ones, yes.
Yeah.
Were
Yeah.
there.
Array. So,
That was the design. When you designed it, it was in your paint, I guess.
रुक जाओ दिखा 4 channels. Just for Nexus.
Sir,
Double understanding.
yeah, so the question was,
Mm-hmm.
these algorithms that you mentioned now,
Mm-hmm.
they are based on a box or they're based on per channel. So maybe I have 2 port channels.
Based on the per channel. Based on the per channel. So if you have 2 channel, I can change it for
Yeah.
the different thing. Yeah.
Okay.
And one more
Cool.
thing. Thanks for remembering this part. So your one switch can be forwarding the packet based on the source and destination MAC. The another switch can forward the port channel load balancing based on the source and destination IP as well. So it's fine. Combination, you can also use it.
Yeah. Okay. So that's good. Now the question I asked earlier was, when in our design, when we had this port channel for these 4 different ports, and we made it as layer 3, and the others were on layer 2. So between 2 and 3 we were on layer 3, and between 1 and 2 and 1 and 3 we were on layer 2.
Can you repeat one more time? So you say that you have a 4 ports. Okay.
If you look at the original design that we made for our switches.
Okay. 4 ports. Okay.
No. We had 3 switches, right? So
okay,
yeah,
that's one. Okay. Sorry. Yeah. Go ahead.
So when you asked me what is the issue with this one, so I said, okay, how the traffic flow, because one port channel is layer 3 and the other port channel is layer 2. So yeah, that question still stands. Yeah, this one.
Okay. No, I made this as a port channel layer 3 so that I just can show you the configuration of the layer 3 port channel as well, nothing else. I made this, it was a layer 2. I made it to the layer 3 just to show you that, nothing else.
But still
so if it was a layer 2, right? And the question was, if it is a layer 2, then what happened? This port go in the blocking state, right? So for the complete port channel, because of the spanning tree protocol behavior. Right now, this is the bundling, this is the bundling, this is the bundling, and this is the bundling, right? Then what happened? This will go in the blocking state. So in that case, this is the root bridge, and in that case, you can do that. You can change the root bridge to the switch 2. Then what happened? This port will be not going the what do we call? How do we call this guy? Blocking port, right? So they will in the powering. So, but still, this port will go in the blocking. Any one of them, of course, they will do that. Any one of them go in the blocking one. That's again, that's a problem in the port channel. This is the problem. The problem with the spanning tree protocol, we were blocking all the ports. We removed this thing with the help of port channel, but still there is a problem in the port channel. And this solution is the vPC. If anyone heard that.
Yes, sir.
Yeah, this is the solution in the vPC that we have. I will show you the use case of the vPC and the design as well. Don't worry about that. Abbas, is clear to you now?
Yes, sir. Thank you.
Okay. So yeah, this is the balancing algorithm, man. I will check this rotate matlab. Okay. I think so. The meaning of rotate, as I'm understanding right now, they will rotate the traffic based on the, some requirement of there. I will check it and let you know for the meaning of rotate.
Sure, no problem. Actually, I have not even I've not
Even I have
noted
never
actually.
seen it.
I have not noted actually before.
Yeah. Is that good?
Yeah, I'm good with that. Yeah.
Okay. Anyone has a doubt in the port channel concept, guys? If I not, then I'll move forward a little bit
So,
more.
as a business requirement, should we always go for layer 3 for LACP, or should we just stick with L2?
Okay, that's a good question. Okay, let me tell you one thing. Forget the business requirement, understand the requirement first of all, the company requirement. We have a server and we have a server. Okay, so the switch 1 and the switch 2. So this is the Nexus. Let me tell you that. Don't think about this, the catalyst. This is Nexus. Okay, I have a connectivity like this way right now. Okay. If I'm going to do the layer 3, understand in this case, then what happens? I have to be in the different subnet, right? Right now, I have to be in the different subnet. This guy in the 1.0, this guy in the 2.0, right? But let's say example, if I want to do the DC migration or DC availability, whenever the one data center goes down, I have another system backup. And when I'm going to do the VM migration, the requirement for this guy is what? I need to be the connectivity at the layer 2 level, not the layer 3 level. In that case, can I go with the layer 3? I have to be a layer 2 network. This has to be in the same side. In that scenario, what we have to do that we need to go and configure this port channel as a layer 2 port channel, not the layer 3. If there is no requirement of such case, I just need to have a connectivity between the server 1 and server 2. Then you can go with the layer 3 as well. Not a big deal. Clear now? Okay. Now the next point is what about the LACP? That's a little important. Normally what happens, your LACP packets are exchanged at the 30-second, right? So 30-second, what happens, the switch is going to send the LACP packet to the switch 2, right? At every 30-second. So what happens if the remote end switches, right? If the remote end switch 2 is not get the switch 2 is not get the LACP packet from the switch 1 for the 90-second, then what happens, the switch 2 will consider my neighbor is dead. My neighbor is dead. And he will take the role of the master. So in a LACP, what happened? We have a role of the master and standby. So this guy will become the master and this guy will stand by, right? Because of the base priority. So if the master goes down, then what happens? Standby will become the master. But again, I have to wait for the 90-second. This 90-second, right, is a very, very long time. Can you imagine 90-second, how much packet it will drop? So to avoid this problem, right, we have introduced the concept is called as LACP fast. In LACP fast, what happened? I'm not going to send the packets in a 30-second. I'm going to send the packet in the 1 second only. Right? I'm going to send the packet in the 1 second and I will set the default timer 3 seconds, right? Depend on me. So that if the guy is not receiving the LACP packet in the 3 second, I will make sure that this guy is down and I will become the master over there. So from 90 to the 3 second, I will converge this network. So the LACP, initially it was a slow, but then later on what happened, the switches has introduced, Cisco has introduced the LACP fast interval. And based on that, what happened, we can make a faster convergence between the switches over there. We'll do this lab when I'm going to teach you the vPC, right? I'll show you how you can achieve the faster convergence. This features is also there in every devices. Even you can go in the XR, it's there in the Nexus also is there, right? So that's basically improving the faster convergence for the LACP protocol. That's all about the LACP, guys. Anybody has a question, you can feel free to ask me about the port channels.
One question asked by Baz, I believe,
Yeah.
that
I
why
missed
we
that. Maybe I missed that one.
yeah, access port, I think.
Yeah, right.
Yeah,
Which
thank
one?
you for reminding me. I almost forgot.
Yeah, even I forgot that. Okay. So switch 1 and switch 2. Okay, think about it this way. Okay, and I can do the port channel between the server and switch, right? This is the on mode. And also I mentioned that your new server that is coming nowadays, they do support the LACP protocol, right? So never confuse with this term. So previously I was using this kind of scenario, like, server do not support the LACP protocol. You have to go with the on mode, right? But it's not like that. Recently, 7 to 8, 10 days ago, I have encountered this situation, right? Where the new servers are coming, they do support the LACP protocol. So understand this is the non mode right now. The server is running, and this is the LACP we are running over there. So, and this is the user who is sitting behind this guy, and they have another user over there. They are the part of the VLAN number 10 and the VLAN number 10, right? And this guy is also part of the VLAN number 10. So now tell me, what do you think? Which ports are the? Let me write on the ports 0/0/0/1, the port channel 1 and port channel 2. Tell me which ports are the access central over there. In front of you, you have a complete scenario.
So this is the access network. So the P2 will be access.
P2 कैसे access देगा? This should be the access port. This should be the access port.
P2 will be trunk and PC
P2
side
will be trunk, and this should be the access, right? So your port channel can be accessed if they are carrying the single VLAN traffic. Your port channel can be trunk if they're carrying the multiple VLAN traffic. Is that clear now?
It means they can only be accessed if they having means in our network if we have only one VLAN. Is that so?
Yeah.
That is not
Then you can
possible.
make this guy access. So our topology that we have, let me show you that. We can do one thing now.
So what is the device? What is the device on connected to P1 on the other side, on the A side? Is this a server?
This
or
one?
is this a no?
This
on,
is
on the, this is server. Okay. Now this is where the confusion comes in. Now, why would people go for network teaming inside a server? And when should we use network teaming and when should we use LACP on the switch side? So sometimes there's a confusion there.
Okay. So let's put this leave this confusion till this point, till the ACI comes in the picture. Okay. So in ACI, so one of the major problem is what? Why the network is gonna talk about the server, why the server is gonna talk about the network. They always have a fighting between the network and server side, right? So that's why ACI solve this problem.
No, but sir, without ACI also when we
let's go with without ACI. Come to the question.
Now if you put two network cards on S1.
S1 take it. Okay, NIC1, NIC2.
NIC1, NIC2. Should I you on Hyper-V or on VMware, should I make network teaming on the server side and make it a logical one port? Or should I and do nothing on the server switch side, or should I just work on the switch side and make it LACP and do nothing on the server side? So which is the right approach to do it?
Okay, the first of all, does your server support the LACP?
Sometimes no, sir. Old
Sometimes
servers.
not. Then how you can enable the LACP over there?
So we go with network teaming.
We have to go with the on mode on the network team.
Binding.
Manually configure the port channel.
Okay.
Okay. And then you need to inform the server team. You can put this guy into the bundle.
Okay, makes sense.
Okay. And then you can achieve the bundling over there.
So still we have a port channel.
Yeah, of course, we have a port channel.
Okay. Now this is on because now if that server supports LACP, then we can run LACP.
Yeah, then it's fine. Then there's no problem.
And do they need to be active both sides?
Anything is fine. Active, passive, anything is fine for me. Because in
so what
happens
for passive? I don't get a reason for passive to be used in anywhere because active works fine. Why should anybody be using passive in any case?
Okay, that's also part I'll tell you. So active is what? I can initiate the request. I have a complete control. And I can accept the request. Passive is what? If somebody is giving the request to form the port channel, then I will form the port channel. I cannot send the request to form the port channel. Now you tell me one thing. In the case of server and switch, switch is fine. But in the case of server and switch, what do you think? Who will be the main leader?
switch.
Right? So in that case, what happened? You need to configure this guy as active, right? And this guy should be the passive.
Now, sir, if you ask a system engineer, he will say, no, I'll initiate it. If you ask a network engineer, he will say, no, I will initiate it. So
So
there's a fight.
can you repeat your question? Okay, not saying.
So it's a tricky question, because if you ask the server administrator, he will say, no, I will initiate it. But if you ask a network engineer, he said, I will initiate it. So better just keep it active in both sides.
Yeah, you can keep the active. That's what I'm saying. Right? You can keep the activity both sides. There's no problem in that case as well.
Yeah. So that's what I'm saying. I don't see any reason for anybody to do passive at all. There's no reason to do passive.
See, personally, if server team and network team both are agree, you can make the passive and active so that the switch one has a full control. If they are not agree, then you have to go with the active scenario.
Yeah. Okay. Yeah.
It's like the policeman and the lawyer, right? They cannot be same, right?
Yeah. Yeah.
All good, guys. So that's all for the port channeling. We have more things about the vPC. I will clear the few myths about the vPC as well in the vPC topic when I'm going to talk about the Nexus part in the next month. No, of course, not now. All right. So even I have seen that people has a mini confusion. Like I have seen that personally. People are used to say, okay, if you heard this part, this vPC peer link has to be the port channel. Right?
So, yeah.
Why should I care about it, man?
So is
So
it
we'll
not true?
discuss this part as well, right? In the vPC. So vPC also has a good discussion on the vPC part. We'll discuss about the design level and troubleshoot level as well. Okay. So in the next weekend we have a plan. Let me tell you that. We'll move to the FHRP protocol, right? The HSRP and VRP, and then we'll move to the routing part as well, right? So that will finish the routing, and then we'll jump to the Nexus and the vPC, BDC, the fabric path, and those things. So we are not going to spend so much time on the fabric path and the OTB. The reason I'll tell you, because these technologies are totally legacy now. Nobody is using it, but it will clear your concept about the VXLAN. Your understanding of the VXLAN will be more clear if you understand the fabric path and the OTB. So that's why we'll spend not more than 1 hour. We'll spend the 3 hours on the both case, so that we'll have a clear picture of this thing on the VXLAN. Okay.
Sir, I want to request. Last time I requested, can you make me a change in one of the designs so I can use it under ASA on one of the labs you made, because I can't make a ASA, or I can't make a change in the design. So you have a lab.
networking slab, right?
Yes. So if you can just add a ASA on one of those and connect it to a switch, I will then start using it for my work.
I'll do one thing. I really forget yesterday, man. I'm telling you, I was a little busy yesterday. So I'll do one thing. I'll talk to the today only, and I'll update you in the group by today or maybe the tomorrow morning. I'll update you in the group like how you can make some changes. Okay.
Another thing about what you can do, sorry to cut you, like you can also talk to networking, like like if you want to put your own topology, you can give the topology, like you can make it in EVNG and you can give it to them. They will upload it into their own servers.
I don't have a EMG. That's why that's why I can't send it.
That's the issue then.
Yeah, so that's why I'm trying to use this available EVNG. So I don't have an infrastructure to run EVNG with me.
अरे कोई दिक्कत नहीं है भाई. I'll do one thing. I'll talk to the networking team. You guys don't worry about that. Okay. I'll help you with all cases, right? Okay. I'll talk to the networking. He will help you definitely. Don't worry about that. Okay.
Yeah, that's all right. Yeah.
We'll do the fun in the lab. Don't worry. We'll have lots of scenarios, and whatever the doubts you have, guys, please do one thing. Better to put in the group, WhatsApp group, right? Whatever the production doubts you have, you can put in the WhatsApp group. I will definitely help you within a 1 hour to 2 hours. If I'm busy, I'll have to take the 3 to 4 hours to solve it, but I'll definitely solve it so that we can save the time in the class. In the class, we can do something else.
Yeah, that's correct actually.
Sir, add कर दो ना, मेरे को added नहीं हुआ अभी.
Yeah.
Now, just one query on the port channels. We can have multiple sub interfaces for a single port channel as well, right? Or
Yeah,
Yeah, we
you
can.
can have it. It's
is there
this.
any scenarios for that? Can you quote something
Yeah.
where
One minute.
exactly it comes into?
Let me add the Puneet's number, and then I'll come to your question. 999 571 and 363. Hold on. I've already saved this number. Puneet. Let me add you in the group. Where do you see that the port channel has a sub interfaces, dude?
I've seen few examples in some ASRs or some.
ASR is there, right?
Yes,
ASR is
yes.
there. Yeah, in the ASR is there. That's why I'm saying that. In the ASR, normally what happened, what you can do that. So let's say example. So this is the layer 3 bundle interface we have, B interface, right? And this bundle interface has a bunch of physical links. And I want to send the layer 2 VPN connectivity, right? Between the router to the service provider, right? I want to segregate the router service provider, and they have to carry the particular VLAN traffic. Can I do on the L3 bundle V3 interface? No, right? So what we can do that, we can, let's say example, this is the bundle 100, and we can break down to the 100.1. That's, I will make the encapsulation will be 100. I'll make this guy's a 100.2. I'll make this guy's encapsulation will be VLAN number 2. So this is the VLAN number 1, and this is the VLAN number 2. And I can route the VLAN traffic on this particular interface by breaking down the bundle interface into the sub interfaces over there. That's our logic behind the breaking down the sub interface. Sub interface, the reason to create the sub interface so that he can carry the L2 traffic, L2 VPN traffic. But all the bandwidth they will utilize from the B interface. If the B goes down, all your sub interface goes down. All good?
Yep.
So that's a main use case in the ASR router. You have seen that, right?
Yeah,
That's
mostly in ASR only. Yes.
mostly in ASR.
Yeah.
Well, between the service provider and the customer side.
Right.
Anyways, that's a good fun, man. We'll do the move on in the HSRP. Bring your HSRP question. Think about the HSRP protocol for the next 1 week and bring your all question, right? We'll talk about the next weekend, the design of the BFD as well, over the HSRP protocol. Should I enable it or not? Okay.
Okay, fine. Thanks,
Chalo.
Flo. Thanks, team.
Okay,
Thanks.
Okay,
thanks.
take care.
Thanks, man.
Thank you.
Happy weekend. Bye.
Yeah. Thank you, everyone.